For ninth grade, 7-8, the difference of squares. This is on page 444. This one is a really easy section if you know the formula. So here you have a squared minus b squared. So if you see a binomial where the first term is a perfect square and the second term is also a perfect square, and it has to be a subtraction problem. So it's a difference of squares, which means it has to be minus between. Then you can take the first one, take the square root of the first term and the square root of the second term, put each of them in parentheses, one with a plus and one with a minus. Or you can switch around the order and put the minus first and the plus second. Okay, so let's do these very quickly. This one, the square root of 81 is 9. So the perfect square factor here is 81, and then you've got 9. And then the square root of c squared is c. So you have two parentheses with 9 and c. And then one has a plus and one has a minus. And then you're finished. Same thing here. The square root of 64g squared is 8g minus h. And then 8g plus h. Okay, I want you to check your answer also, because remember, the first term multiplied by the first term should give you the first term in the binomial. And the last term multiplied by the last term should give you the last term in the binomial. So 9 multiplied by 9 is positive 81. C multiplied by negative c is negative c squared. So we know that we're correct. Same thing here. 8g multiplied by 8g is 64g squared. Negative h and positive h is negative h squared. Here again, this one has two terms that have an x in it. So first, what you're going to do is factor out the greatest common factor. They have a factor of x. So we're going to factor that out. And we get 9x squared minus 4. Now, I knew to look for that because this one is cubed, and a cubed term is not a perfect square. So I would have to have a squared term or a fourth term or a sixth term or an 8 or something that is divisible by 2. Here again, you can't take a perfect the square root of an x. It would just stay under the square root. So we wanted two numbers that are perfect squares that you can take the square root of without getting a decimal or just a random letter under a radical. Okay, so now we can see that 9x squared is a perfect square and 4 is a perfect square. So we're going to leave the x in the front and take the square root of each term, 3x minus 2 and 3x plus 2, and then the x would stay out front. So this would be our final answer here. Here again, I have a 3 here, so that clues me in that I don't want, I need to take out a y. Also, this is a positive, and we want a difference. So because there's a minus in the front, I'm going to take out a negative sign and the y. So that when I divide by negative y in both, the positive divided by the negative will change that to a minus sign, and this will change it to a positive sign. So I'm going to have 4y squared minus 9 left over. And now this is a difference of squares because 4y squared is a perfect square and 9 is a perfect square. So let's go ahead and finish factoring. The negative y stays out front, and inside I'm going to have 2y minus 3 and 2y plus 3. Okay, so that's it for that. These are the same, except for it's a 4. So when I take the square root of a fourth term, I'm going to get 2 left. So this one is y squared minus 1, y squared plus 1. Now, when you have a 4, you need to make sure that you can't factor anything else. So if I look at this one, I'm still doing difference of squares, and I notice that this has a minus sign. So if y squared is a perfect square, which it is, and if 1 is a perfect square, which it is, then I can do this again for the y squared minus 1. So my final answer would be y minus 1, y plus 1 times y squared plus 1. So the y squared plus 1, you can't do anything else with that because it's a plus sign in the middle. but the minus 1 is still 2 perfect squares, and so I can separate that into 2 more perfect square factors, and so this would be my final answer. Here again, this one, we have 2a squared minus b squared, and 2a squared plus b squared. So I have to look at this one. 2 is not a perfect square, so actually this one would be finished because I cannot take the square root of 2a squared and get a whole number. I would get a decimal here. So I'm going to finish with this. This one is 9 minus x squared, 9 plus x squared. 9 is a perfect square. 9 is a perfect square, and so is x squared, and this is minus, so I can further simplify this one by expanding to 3 minus x, 3 plus x, and then I still have the 9 plus x squared. So I have 3 factors here, and then I'm finished with that one. 16y is 4y squared minus 1, 4y squared plus 1, and 4y squared is a perfect square, and so is 1. So this is 2y minus 1, 2y plus 1, and your 4y squared plus 1. In example number 3, they wanted you to do a mixture of things. So if I notice here, I have a 2 and a 50, and both of those can divide by 2. So I'm going to factor out a 2 first. So I'm left with y to the 4th minus 25. And then y to the 4th minus 25 will simplify a little bit more. So I have y squared minus 5, y squared plus 5. Now y squared is a perfect square, but 5 is not a perfect square, so I'm actually finished now with this problem because I can't do anything else with y squared minus 5. 6x to the 4th minus 96. Let me do this one in red so you can see it a little bit better. I'm going to pull out a 6 because both numbers can be divided by 6, so that's the greatest common factor. So I have x to the 4th minus 16. And then x to the 4th is a perfect square, and so is 16. So I have 6x squared minus 4, x squared plus 4. And I can do it one more time because x squared and 4 are both perfect squares. So my final answer then would be 6x plus 2, x minus 2, and then x squared plus 4. So that's a long one, but easy enough. Okay, when they give you 4 terms and they want you to factor it, every single problem that they have done in this chapter that has 4 terms, you're going to split it in the middle and factor out the greatest common factor and put those together. Like what we did for 7-6 and 7-7. Actually, it was only 7-7 that we did it the long way. So I'm going to split it in half and then factor out the greatest common factor here and put it into 2 binomials. So here my greatest common factor is m squared. So I end up with 2m plus 1. And here my greatest common factor, if you have a negative in front, always take a negative with it. So negative 25 is my greatest common factor. And when I divide here, I get 2m plus 1. So if you remember, what's in the parentheses is the same. And so when I write the actual factors, I'm going to have m squared minus 25 multiplied by 2m plus 1. And here I can see that m squared minus 25, both of those are perfect squares. So I'm also going to have to do m plus 5, m minus 5, and then 2m plus 1. So these 3 are my factors for this one. And then the last one, I'm going to split it in the middle again. I have r squared for my greatest common factor. So I have r plus 6, and over here I have 11, r plus 6. So my two factors are r squared plus 11 and r plus 6. Now this one, neither of them are minus, so I can't do anything else with these. These are finished. And this would be my answer. Okay. The last one on page 400 and... Let's just look quickly at this one. On page 446, this one is a multiple choice question. So I really wanted to show you how to do multiple choice questions. If they give you answer choices and you want to know which one is the solution, very easily you can take the answers and plug them into the equation. So, for example, 0 was one of the answer choices on a couple of these problems. So 0 cubed is 0 times 18 is 0 equals 50 times 0, which is also 0. So when I plug a 0 into this equation, I'm going to get 0 equals 0. That means that that is a solution because 0 does equal 0. So I know that 0 is one of the solutions. That means that G cannot be the answer because 0 is not in that answer choice. And J cannot be the answer because 0 is not in that answer choice. So then I only have to decide, because they both have 5 over 3, I'm not even going to look at 5 over 3 because 5 over 3 has to be a solution since it's in both of the answers that are left. So I'm going to try negative 5 over 3. So I'm just going to take 18 multiplied by negative 5 over 3 cubed equals 50 times negative 5 over 3. So here I just took negative 5 over 3 and put it where the x is. Okay, when I put this in the calculator, I get negative 83.333 forever. And when I put this into the calculator, I also get negative 83.333 forever. Okay, so this, because these are the same, I know that negative 5 over 3 is also a solution. This one doesn't have negative 5 over 3, so H has to be my final answer. So I didn't actually even have to solve that equation. So on your test, if it's multiple choice, which it is, any of them that have an equal sign, if you will just plug your answers in, you don't actually have to solve it, or you don't have to take all the time to solve it. Now you can solve it if you want to, in which case I would move this over and make it minus 50x. And then I would factor out a 2. So it would be 9x cubed. Actually, I would factor out a 2x. So let's go ahead and factor it. 18x cubed equals 50x. So I would subtract 50x because they have to be on the same side. I would have 18x cubed minus 50x equals 0. You're going to factor out a 2x. So that you have 9x squared minus 25. This factors to 3x minus 5 and 3x plus 5. You still have a 2. And then you would have to take each of these factors and set it equal to 0. So I have 3x minus 5 equals 0, plus 5 plus 5. Divide by 3. So 5/3, 2x equals 0, divide by 2, so x equals 0. Here's your second answer. So you have 1, 2, and then you have one more, 3x plus 5 equals 0, minus 5, divide by 3. So negative 5/3 is your last answer. So 1, 2, 3. But that takes a lot longer than if you just plug in answer choices. So you can do it either way that you want. It's up to you. But it is multiple choice on this test. So whichever way would be easier would be what I would do because you only have 2 hours for the test. So good luck.